Next topic is powers of I. So we have seen that what is I? I is equal to root of minus 1. Now what is I square? I square is equal to minus root of minus 1 square is equal to minus 1. Now I cube can be written as I square into I square is minus 1 into I is equal to minus I. So I cube is equal to minus I. Then I raised to 4. I raised to 4 is equal to I square into I square. I square is minus 1 into minus 1 becomes 1. Now the next power, what is I raised to 5? I raised to 5 we can write I raised to 4 is 1. So that is easy. We can write as I raised to 4 into I. I raised to 4 is 1. 1 into I is I itself. I raised to 6 is I raised to 4 into I square. I raised to 4 is 1. And what is I square? Minus 1. So that's equal to minus 1. Now I raised to 7. That is I raised to 4 into I raised to 3. Or you can write I raised to 6 into I. That's also correct. So 1 into I cube. What is I cube? I cube is minus I. So 1 into minus I is minus I. Now I raised to 8. Anyway, you can split, okay? Here I am writing I raised to 4 into I raised to 4. Since I raised to 4 is 1. So 1 into 1 is equal to 1. So a pattern like that. Look, I square is minus 1. I square is minus 1. I raised to 6 also minus 1. I cube is minus I raised to 7 also minus I raised to 4 is 1. I raised to 8 is 1. Okay. So the fourth power. Like that when I raised to 9, I raised to 9 is I raised to 8 into I. So I raised to 9 is I itself. I raised to 10 is I raised to 10 becomes I raised to 8 into I square. So it is minus 1. So the order is like this: I, then minus 1, then minus I, then 1. Then again repeats this like that. Okay. So the fourth power gives the value 1. Now what about the negative values? Negative also we can take. What is I raised to minus 1? I raised to minus 1 is 1 by I. 1 by I, 1 we can write as I raised to 4 by I. So it is I cube. What is I cube? Minus I. So I raised to minus 1 is minus I. I raised to minus 2 means 1 by I square. I square is minus 1, so total is minus 1. I raised to minus 3 is 1 by I cube. 1 by I cube, how we write? 1 we can write as I raised to 4 by I cube, so that is I. Then I raised to minus 4 is 1 by I raised to 4. I raised to 4 means 1, so it is 1. So here the order is minus I, minus 1, I, 1. There also the fourth power negative, but it is 1. So you have to learn the first 4. That's enough. Okay. I is, wherever I comes we write I itself. Don't give the value root of minus 1. Okay. I as I itself. If there is I square, you have to give the value minus 1. And I cube is minus I raised to 4 is equal to 1. This you have to learn. Then if negative power come, you have to write in the denominator and solve it. Okay. Then we generalize, that is I raised to 4k, the multiple of 4. If the power is multiple of 4, that is always 1. Then I raised to 4k plus 1, that is this 4k and next one more I. So that becomes I raised to 4k plus 2, that is I raised to 4k into I square. I square equal to minus 1, so that is minus 1. Then I raised to 4k plus 3. That is I raised to 4k into I cube. I cube is minus I. So, example. Check the example, children. If it is I raised to 37. If greater power, the power is 37. So, you have to split as the multiple of 4. What is the nearest multiple of 4? It's not above this number, below. The nearest multiple is 36. 4 nines are 36. Then I can write into I. Exponent rule, a raised to m into a raised to n is a raised to m plus n. So, we can split like this. Then I raised to 36 means it is the multiple of 4. I raised to 4 raised to 9 into I raised to 4 is 1. So, 1 into I. Or you can skip these two steps. I raised to 36. 36 is a multiple of 4, so it is always 1. So, 1 into I is equal to I. If it is I raised to 100, I raised to 100 is I raised to 4 raised to 25. Is it correct? 25 into 4 is 100. So, that is equal to 1. Like that any number you can solve. I raised to 76. Is 76 multiple of 4? No. Is it a multiple of 4? Yes. 76 by 4, 1, 4, 36, 19. So, I raised to 4 raised to 19. So, that is equal to 1. If I raised to 73, so I raised to 72 into I raised to 72 is 1. So, you can write I. In that way you can do. Okay. So, you have to learn the first 4. Okay, children. The first 4, that is I is equal to root of minus 1, I square is minus 1, I cube is minus I raised to 4 is 1. Then multiple of 4, generalize, I raised to 4k is always 1. So, if it is I raised to 19, we can write as I raised to 16 into I cube. I raised to 16, multiple of 4 is 1, I cube is that you have to learn by heart it, minus I. So, that is equal to minus I. Okay. Then negative, if power is negative, write in the denominator, then using this result or rationalize the denominator, then you can. Now, next is the square root of a negative real number. So, if it is root of minus 3, it is not a real number, it is an imaginary number. So, how we write is, we can write minus 1 into 3. Okay. Then we can split as minus 1 into 2. So, that is equal to root 3 into this root of minus 1 is same as I. That way you can write. So, whatever negative number comes inside, we can write as root 19 I. Root of minus 23, that is root 23 I, or minus 25. Root 25 I, that is same as 5 I. That way you can write. Okay. Then, but what is 3I whole square? 3I square means 3 square into I square, that is 9 into minus 1, that is minus 9. And what is minus 3I whole square? Minus square is always positive. Again 3 square into I square, 9 into minus 1, that is equal to minus 1. So, if x square is equal to minus 9, like if x square is equal to 16, you know how to write x. X is equal to plus or minus 4. Plus 4 square and minus 4 square gives 16. Like that, here if x square is equal to, that is if x square equal to minus 9, then we can write x as plus or minus of this root of minus 9. Okay. Or x as plus or minus 3i. Isn't it? 3i square gives minus 9, minus 3i square also gives minus 9. So, we can write like this. But this root symbol, that also you have studied, this root symbol indicates only positive value. Root of 25 is plus 5 only. But x square equal to 25, then you can write x as plus or minus 5. That is the difference. Understood the difference? This root symbol indicates positive value only. So here when I write root of minus 9, then we have to write only positive 3i. We can't write minus 3i since this sign indicates positive value. Okay. Now the next is root of. We know that root a into root b is equal to root ab. Root 2 into root 3 we can write as root of 2 into 3, that's equal to root 6. Here a and b are positive numbers. I took positive numbers. If one is negative, if one number is negative, for example if 2 is negative, so minus 2 into root 3, then can we write like this form? Minus root 2 into 3, minus root 2 is same as root 2i, root 2i into root 3. So that is root 2 into root 3 is root 6i. What about the right hand side? If we write together minus 2 into 3, that is equal to root of minus 6. That is same as root 6i. So these two are equal. That is, if one number is negative, then also this result true. If 3 negative, what happened? Look, root 2 into root of minus 3. That is root 2 into root 3i. That's equal to root 6i. Then if we combine and write like this, that is root of 2 into minus 3, that is root minus 6, that is same as root 6i. So both are equal. Then if both numbers are negative, so here first I took both are positive numbers, then I took one of the number negative. Then also this result true. Then if both are negative, that is root of minus 2 and root of minus 3, is this result true? Root of minus 2 and root of minus 3, the left side, I am taking only left side, this root of minus 2 I can write as root 2i into root 3i. So root 2 into root 3 into i square, that's the meaning. Root 2 into root 3 is same as root 6. I square is minus 1. So it is minus root 6. That is the left side. Okay. Then what about the right side? If we write together inside the root, minus 2 into minus 3 is 6. Are they equal? You compare? Not equal. So what we can conclude? Root a into root b equal to root ab is true only if both numbers are positives or one of the number is negative. If both are negative, this result does not true. So that is also important. Okay. So root a into root b not equal to root ab if a and b are negative numbers. Okay. Otherwise, if a and b are positive numbers, if one of the number is negative, one is positive, then also that result root a into root b equal to root ab true. Okay. The next is the modulus and the conjugate of a complex number. So let z is equal to a plus I. Then the conjugate of z, conjugate of z is denoted as z bar. The notation is z bar. That is defined as, which is equal to a minus ib. So if z is equal to a plus ib be a complex number, then its conjugate is denoted as z bar, that is defined as a minus ib. For example, if z is equal to 2 plus I3, then what is z bar? 2 minus I. Or if z is equal to root 3 minus I5, then z bar is equal to root 3 plus I root I5. Okay? The middle sign you have to change. Now that is the conjugate. Now what is the modulus? The modulus of z, the modulus of z is a complex number. The modulus of z is denoted as mod z and is defined as mod z is equal to root of a square plus b square. That is, modulus of the complex number is equal to root of real part square plus imaginary part square. So mod z square means a square plus b square. Okay, so these two you have to learn what is conjugate of a complex number and what is modulus of a complex number. Now, what is a multiplicative inverse? Multiplicative inverse of z. Z equal to a plus ib is 1 by z, isn't it? So 1 by z means 1 by a plus ib, and a plus ib is an imaginary number. We have to rationalize, so we have to multiply by its conjugate. What is the conjugate of a plus ib? That is a minus ib multiply, denominator also we have to multiply. Okay. So a minus ib by, here a plus b into a minus b form. So a square minus b square. B square means second term square. That's equal to a minus ib by a square minus I square b square. What is I square b square? I square is equal to minus 1. I square is equal to minus 1, so it is a square plus b square. Or I can write 1 by z is equal to, the numerator is z bar by, what is a square plus b square? Mod z square. Or I can write mod z square is equal to z into z bar. So this you have to learn. Okay. Mod z square is equal to z into z bar. So what is the conjugate? What is the modulus of a complex number? The conjugate of a complex number is z equal to a plus ib is a minus ib, then notation is z bar. The modulus of a complex number is mod z, that's equal to root of real part square plus imaginary part square. We don't take here I, just the number part only, the real part, real number. A and b are real numbers. When I is there, then only we call that part as imaginary part. So just we take the numbers a and b squares. Then multiplicative inverse is 1 by z, that you have to rationalize. So we can see that mod z square is same as z into z bar. Then some properties are there of conjugate and modulus. Mod z1 z2 is equal to, now proof for this. Mod z1 z2 is equal to mod z1 into mod z2. Second one, modulus of z1 by z2 is equal to mod z1 by mod z2, provided the denominator cannot be same. Then conjugate, the first property, z1 plus z2, the whole bar is z1 bar plus z2 bar. Minus also, z1 minus z2 whole bar is z1 bar minus z2 bar. So together we can write the second one z1 z2 bar, z1 bar into z2 bar. You can prove when you take an example, then you can prove all these. z1 by z2 whole bar is equal to z1 bar by z2 bar. Okay, now look one example. Z bar is equal to 2 minus I3. What is Z bar? The whole bar. That is Z bar bar. So take the conjugate of this. That is 2 plus I3. That is same as. Okay. So that also another property. Z bar bar is equal to Z. Now problems. Find the multiplicative inverse of root 5 plus 3i. So let Z is equal to, we have to name the complex number. It is by the letter Z. Multiplicative inverse means 1 by Z, 1 by root 5 plus 3i. So next step you have to multiply by the conjugate by root 5 minus 3. Okay. Now multiply. Denominator always in the form a plus b into a minus b. So a square minus b square. B square means 3i square. Root 5 square is 5. I square is minus 1. So it is always plus. When you take like this, it is always plus 9. So 1 by z, multiplicative inverse 1 by z is equal to by 14. You have to split like this, real part and imaginary part. 3 by 14. So what is the real part of this complex number? It is also a complex number. Root 5 by 14 is the real part. Imaginary part is 3 by 14. Okay. Or we have that result, mod z square is equal to z into z bar, or what is 1 by z. 1 by z is equal to z bar into z bar by mod z square. This is the second method. Okay. This one method we write the inverse, then we multiply by the conjugate, so we get the answer. The other method is we use that result. The result is mod z square is equal to z bar. Okay. From this. Or you can learn this. 1 by z is equal to z bar by mod z square. So we can use that. What is z bar? Z is root 5 plus 3i. So z bar is root 5 minus 3i. Then what is mod z square? Z is equal to root 5 plus 3i. So mod z means root of a square plus b square. A square means root 5 square plus b square. Just the number, don't take I. So it is 5 plus 9. That's equal to root 40. Mod z is root 40. So what is mod z square? It is 40. Okay. So I can write root 5 by 14 minus 3 by 14. So which is easy for you, that method you can use, either that method or this method. So this is the way we can find the modulus. Okay. Take the first number square plus the second number square. Now the next one, express in the form a plus ib. So it is a complicated expression. We have to simplify and write in the form a plus ib. So the numerator you have to multiply, it's product. But it is of the form a plus b and a minus b. So I can write this equal to a square minus b square. There you have to take I, okay, by, and here subtraction, root 3 plus root 2I minus root 3 plus I root 2. That is root 2I itself, these two cancel. So numerator is 9 minus I square is minus 1. So plus 5 by root 2I, that is 2 times root 2I. So 14 by 2 root 2I. 14 and this cancel, 7. So 7 by root 2I. Again we have to rationalize. Okay. So 7 by root 2I. You have to multiply by root 2I. So 7 root 2I by root 2 into root 2 becomes 2. I into I is I square means minus 1. So this is the answer, minus 7 root 2I by 2. But we have to write in the form, what is the question? Write in the form a plus ib. So this is the only imaginary part, no real part. So how we write? 0 plus, real part is 0, 0 minus. Here 0 minus 7 root 2 by 2. Now the B, question B, 1 minus I whole raised to 4. So whole raised to 4 we don't know how to expand. So we can write as 1 minus I square raised to 2. Then 2 into 2 becomes 4. Then expand this. What is 1 minus I whole square? A square minus 2ab plus b square. Then whole square. So 1 minus 2I, I square is minus 1. So minus 1 and plus 1 cancel, minus 2I whole square. That is 4I square is minus 1, so it is minus 4. So only real part, no imaginary part. So we can write minus 4 plus I0 or 0I, anyway you can write. Okay.